Thanks so much for the kind introduction. Thanks for having me. I'm going to talk today about how do we know what AI can and can't do. And a lot of you guys will probably say something along the lines of testing or evals. And I know a lot of you guys are familiar with evals in general. This is what, for example, benchmarks, which is one subcategory of evals, looks like from the recent Opus 4.5 launch at Anthropic, where you get a bunch of numbers that basically a bunch of skills like agent coding, agentic terminal coding, novel problem solving, bunch of numbers from the specific evidence that the companies are providing to tell you how good a model is along those skills, and then compare that along competitor models. Benchmarks are becoming increasingly important in a bunch of different contexts. One of them is AI governance. For example, in Article 51 in the EU AI Act, they are being explicitly mentioned as indicators to determine whether a foundation model has systemic risk or not. And then if it does, they are basically the models and the model developers facing a lot more regulatory scrutiny and a lot more obligations. They're also being used to steer training decisions and to decide, and for model users to decide, okay, which model might I be trying out for different use cases. First takeaway from this talk, not all benchmarks are good benchmarks. Many benchmarks are poorly designed, which makes it hard to tell if results reflect real capabilities and risks. And this is something that's actually not that clear if you're not on the technical side, if you're not actually working with evals, and where we're actually having a lot of work to do on helping people understand what what evals actually mean, what's behind them, and what information you can actually gain from them. We did some work that we published last year at NERBS actually on BetterBench, where we were looking into different issues with benchmarks, best practices, and we're looking at what actually makes a good measurement instrument. And we talked to a bunch of people from the evaluation community, both model developers, users, benchmark creators, and came up with 46 best practices along the life cycle of benchmarks, from design, implementation, documentation, maintenance, to figure out, okay, how do we actually create a good benchmark? This work actually this was motivated by personally, because I wanted to build a benchmark back 1.5 years ago. And I was really frustrated because there were almost no good guidelines out there on how to do that well. There was literally one blog post. That was it. So we were trying to fill a part of that gap with that work. And we used those criteria to score a couple of different popular benchmarks. And unsurprisingly, what we found is that there are significant quality differences between benchmarks that are being used in production right now. You see some MLU here, for example, GSMAK, barbecue. And in particular, what we find is that there is significant variation across the different lifecycle stages. And some specific things are, for example, that there's insufficient implementation and documentation that limits the reproducibility and scrutiny of benchmarks. So we often actually don't even have enough information about the measurement instrument or the benchmark in particular to know whether it's actually sound or not. And then secondly, which was one thing that I was personally very frustrated with, is that almost all benchmarks fail to distinguish between signal and noise. Which means that when you actually see a benchmark result, you don't even know whether that's capturing actual signal or whether it's capturing some random artifact of the measurement process. And then finally, there's a lack of design information. So many benchmarks fail to report how the concepts that they claim to test translate to the actual set of test items or tasks that are included in the benchmark. And I'll get back to this, the last point in a second. What we also did as part of the BetterBench work was operationalizing those best practices into a checklist for benchmark creators that has been adopted widely by benchmark creators since then, to raise the general quality and standard of benchmarks more broadly. The second takeaway of today's talk is don't take benchmark scores at face value. So the first one was more about the instrument itself. The second one is about the issue that benchmarks often fail to measure what they claim they measure, and that developers' interpretations or evaluation user interpretations can often be very misleading. So coming back, the general point here or issue here is that we're not putting enough emphasis on validity when we're designing evaluations. And in particular, when we're designing evaluations, also making claims based on those evaluations. So validity is generally like the degree to which a test measures what it claims it measures. It comes from like a very like long line of like work on psychometrics, in particular on educational intelligence testing for humans. That's an important part. But it's something like, but there's a lot of like key like principles or like good practices on how to establish like good testing principles and validity as part of like measurement instruments. And coming back to this initial example of the recent Opus 4.5 launch, that was I think like 1.5 weeks ago. And I want to zoom in on one of the specific items here, the graduate level reasoning, where basically Anthropic claims, and this is not just Anthropic, a lot of other developers are doing that as well, that graduate level reasoning, or like a good evidence for graduate level reasoning, is GPQA. And then they give you a score of like 87% and tell you, hey, like that's how good our model is on graduate level reasoning. Let's take a closer look at GPQA. So GPQA is as a data set or like a benchmark of 448 multiple choice questions written by domain experts in biology, physics, and chemistry. And the stated goal of the authors is essentially to study like, to basically like create like methods and to study like scalable oversight. If you now like look at basically like the benchmark and the benchmark's results as, for example, a model developer, you might want to ask, hey, can GPQA be used to accurately capture the construct graduate level reasoning? As an evaluation or like model user that looks at this like bigger table, you might want to ask, like, does a high score on GPQA mean that Claude can write my research paper because it's good at graduate level reasoning? Or you might be a different model user that's like thinking about, okay, can Claude help me solve my high school physics homework? And all of those like 3 claims are trying to make statements based on the same evidence, but they're like vastly different claims that are being made. So what we're looking at in our work measurement tweening, which we're also presenting at a NERVS workshop if you're around, is this kind of like relationship between the object of a claim that you're making, which can either be abstract or like measurable or specific. For example, here, accuracy or intelligence, the claim that you're making based on that. So here we're thinking about examples like the model can be used as a calculator or the model is intelligent, and then the evidence is that's being presented. And then you have basically what you need to do for like this like triplet of information is figure out, are different types of validities like satisfied here? You might want to ask, does your evaluation cover all the relevant cases? And then provide evidence for that. Then you have criterion-oriented validity, where you're thinking about, does your evaluation correlate with a known standard? Is it predictive of real-world outcomes? You have construct validity. This one is in particular applicable to abstract constructs that you can't directly measure, where you need to like figure out, how do I break like an abstract thing like reasoning down into like measurable components, and basically provide evidence that that breakdown is actually valid. And then you might have something like external validity, where you might ask, does your evaluation generalize across settings? This is all, there's a lot of like work, or a lot of like specific like pieces that go into the like evidentiary standards for each of those types that we're covering in the paper. But these are some like general like pointers on like where evaluations can like break down, or like where the pairing between evaluations and evidence can break down. And coming back to this example, here I'm not that convinced that like GPQA would actually be like a good indicator for graduate level reasoning, because it just tests multiple choice questions. It doesn't test like any form of reasoning necessarily, and it's very like constrained to like just 3 subdomains. So the inference that they're making from evidence to the actual claim is like way too like that jump is like way too broad. And I'll leave you with kind of my current take on what I see like could be improved in the field. There's a lot of debate on like what AI capabilities and risks are. And there's a lot of like divergence in like how people look at that. And I think like one of the issues is that our measurement instruments and our like evaluation tools are actually broken the way they are. Fortunately, we know how to fix that, or like we know at least like to make like some progress towards fixing that. I'm almost out of time, but we have a couple of works on that at NERVS that are going into specific evaluation tools and like how to improve them, make them better. And I'd be excited to see all of you there. If you're not there, shoot me a message. Thank you.